All right. Hello, everybody. Um, Thanks for coming to this talk. My name is Oleg Zhurakousky. I am the project lead for Spring Cloud Stream and Spring Cloud Function, the two projects. And yeah, today we're going to be talking about Spring Cloud Stream, kind of a state of the union. We haven't done it in a while, so I guess it is as good time as any to sort of update the community on what's going on, what we've done, what we're working on, what we're thinking, and so on and so forth. Before I begin, question: how many of you are currently using Spring Cloud Stream? Okay, so there is, and how many of you are like not using? Like it's a new thing for you? Okay, so I will. I just like the way I structure the presentation. It is give you like reintroduction of what it is. So for those of you who are familiar, just bear with me. We'll get to the cool parts pretty quickly, but it will give also sort of the introductory level feeling for Spring Cloud Stream. Another question I would like to ask you actually, if you do have a questions, I mean, of course you can ask them at the end, but I personally prefer them in context. So if you do have, if I'm talking about something and you have sort of an immediate question, please raise your arm. I would rather answer it while we're talking about this as opposed to kind of go back. So let's begin. So what is Spring Cloud Stream? In a simple terms, it's Spring Boot-based general purpose framework for writing event-driven microservices. Right. So again, it's a very light way of explaining it. A better way is to look at the image and kind of like explain you what it really does. So your microservice is basically your piece of code, however it is you wanted to implement it. And that piece of code, if it has an input, it's tied to some type of an input messaging system. If it has an output, the same thing, it's tied to, or as we say, bound to a messaging system. That is done through the concept of binders, which we'll discuss in a few minutes. And effectively, you have a piece of code, you have messaging system on the left, messaging system on the right, the data stream from one system to another through your code. And you can, and because of that, you can really create these type of pipelines, streaming pipelines that may interact with the same messaging system, may interact with the same messaging system, but different type of clusters, different messaging systems, and so on and so forth, right? And of course, the data could also come in and go out to non-messaging system. For example, come in from HTTP and go to some type of a database. That is possible as well. So that's really the kind of the nature of a Spring Cloud Stream. So in terms of like some of the architectural concepts, so it is Spring Boot based, just like pretty much everything right now in Spring sits on top of Spring Boot. So provides you a powerful model for writing this type of microservices. We're gonna touch on this in a few minutes. Provides a variety of different configuration properties. We're gonna touch on them as well. Binders for major messaging systems. So like we'll see Kafka, RabbitMQ, a lot of the community binders, some of the binders managed by us, some of the binders are managed by the community. So there is a fairly large following. For example, anybody using Solace? No? They build their entire product on top of Spring Cloud Stream, Solace messaging binder. So actuator endpoints, which is the way to access your internal information about your streams and bindings and stuff. So health checks, micrometer. These are just a few of the major architectural features that Spring Cloud Stream provides. But before we get deep into Spring Cloud Stream, I think it's important for me to cover, as I said, another project that I'm leading called Spring Cloud Function, because while I said Spring Cloud Stream sits on top of Spring Boot, it sits on top of Spring Cloud Function that sits on top of Spring Boot, right? So the core programming model is exposed through Spring Cloud Function. So Spring Cloud Stream is basically a wrapper. You rarely interact with it in sort of an API kind of way. It's just there behind the scene with auto configuration. And the same goes for Spring Cloud Function, and now you'll see it in a minute, right? But let's quickly cover what is Spring Cloud Function. So Spring Cloud Function is a framework that facilitates and promotes the development of functional code using standard Java functions. And when I say standard Java functions, I'm implying Java 8 function, supplier, and consumer, and other interfaces that are provided by within that package of Java functions. Now, why functions are kind of important? If you think about it, and I kind of always pose this rhetorical question. So you either consume data, like if you look at any of the business requirements that you ever had to implement, you either consume data, or you produce data, or you're doing both, right? So the question is, if you think about it, what type of requirement, past, present, or future, you could not implement using functions? The answer is pretty much everything comes down to that level. You consume, you produce, or you consume and produce, right? So, and for that you have function, consumer, and supplier, right? So now, the interesting part about this is that those functional interfaces, they're not Spring. They come from pure Java. So if you look at, here's a sample code, but we'll see I'll be doing a lot of coding in a few minutes. So if you look at this piece of code, if it wasn't for add bean and add Spring Boot application, does it look like a Spring application to you? Is there anything Spring in it, right? So basically, you can implement your requirement using a Java function, introduce it as a bean, and what Spring Cloud Function provides is ability to wrap your function and adapt it to a variety of different environments. You can expose this function as a REST endpoint. You can invoke it via gRPC. You can make it AWS Lambda, all without ever touching the code by simply swapping auto configurations within your POM or Gradle file, right? Those two, the dependencies. So dependencies right now, as you with Spring Boot, not just the libraries, but they provide some state and behavior, and that's really what I'm talking about. So let me quickly go back to that slide. So Spring Cloud Function is the framework that provides you ability to write your business requirements as Java functions, and then include them within your Spring Boot application, and whatever it is you include it as part of your auto configuration that is already integrated with Spring Cloud Function, will use that within the context of that particular execution. So for example, like when we're talking about Spring Cloud Stream, so the message arrives, the message handler, internal framework-based message handler received the message and went through the process and invoked your code, right? So Spring Cloud Function provides that function, that ability to integrate with a variety of different systems and frameworks, right? So it provides additional routing functionality, abstractions via Java functional interface, as I already mentioned, transparent type conversion, composition, and you say, okay, well, composition is provided by Java functions. Like, what do you add as part of Spring Cloud Function? Well, we can compose things that are composable that are not supported by Java function. For example, you can compose supplier and function, which is still going to be supplier. You can compose function and consumer, which will still end up to be a consumer. You can compose supplier and consumer, it becomes runnable, right? So it's those type of things that, for example, in that Java functions composition doesn't support. We provide that additional support for that. And again, all within the concept of a type conversion. So for example, if you compose, like with Java functions, you can compose function with another function as long as the input and output matches the types, right? Otherwise, you're going to get compile error. But with Spring Cloud Function, you can compose regardless of the type compatibility, because our composition also includes the transparent type conversion. So not only on the edges, but also within the composition. So and a bunch of, like I said, a bunch of out-of-the-box adapters and frameworks on top. So Spring Cloud Stream, Web, FTP, RSocket, AWS, Azure. There's a lot to mention, okay? So, so now back to this diagram. This is pretty much what it looks like right now with the Spring Cloud Stream. So your code is actually a function. You implement a function, you include it as a bean, and at this point of time, you're done. And it is really that simple, and I'll show you in a second. So we're going straight to the demo. So I've pre-written some code. I'm going to be using RabbitMQ as a messaging system for these demos, right? And right now I've created, so how many of you are familiar with the start.spring.io? Pretty much by now should be everybody. So typically you would go to, and you would simply say stream, cloud stream, and let's say you pick your messaging system, let's say Rabbit, Spring for RabbitMQ, and click generate, and it will generate you a very basic application. This is what I did, right, before this demo. I eventually included more things in it, but for the very basic, that's all you need, right? And you click generate, and you can start working with it. But before we get into the stream part, let me quickly show you about the function part. So I have an application. The only dependency right here is Spring Cloud Function context. And like I said, Spring Cloud Function as a framework, you rarely, while it's a full-blown framework with the Spring Cloud portfolio, you rarely interact with it directly unless you are the integrator. So I wanted to show you a little bit of the integration part just to make sure that you understand how it works, and it will help you understand how it works within the concept of a Spring Cloud stream. So all I have is a simple function called uppercase, right? And again, I'm using very trivial, simple functions because the reality here is that all we care about is the signature. We never care about what's inside the function because that's your code. That's for you to test, that's for you to deal with, right? It doesn't affect us in any way. What affects us is to be able to integrate the function, discover the types, and provide proper type conversion, composition, and all the other features that we have. So at the core of Spring Cloud Function is an abstraction called function catalog. And we're going to get it from, get being, can't type today. So very simple code. And we got hello back, right? Uppercase hello back. So you're going to ask, like, okay, well, I could have just done it by invoking the bean function, the actual, instead of going to the catalog, get the actual bean and do the same thing. Well, true. But this is where I like to kind of go into a little bit of a debug session and show you what actually happens. So if you look at what we got, like, so I said function, right? But if you look at what we actually got in the uppercase, we got this thing called function invocation wrapper. It's not visible here. Hold up. So Spring Cloud Function Registry inner class function invocation wrapper. So it's actually a wrapper over the function that provides additional functionality. So technically, for example, not just the API-based functionality, but this is the wrapper that will take care of the type conversion, error handling, and all kinds of different things, right? So function invocation wrapper would be the more appropriate type for you to actually cast it to, because then, like I said, from the compiler perspective, you have all these additional methods for the type discovery. So for example, is this function a reactive function or is it imperative function? Is the input type publisher or not? What type of input it provides you, and so on and so forth. So that's pretty much, so if you think about you being an integrator, so now you say, okay, well, I have my own framework. I want to be able to simplify a development for my users. So I'm going to use Spring Cloud Function, and that's really your two lines of code would be your integration points. Because from this point on, whatever the input you receive, you can send it to function, and if it's not, the appropriate type, then we'll do the conversion and everything else. Okay, so that's really it. So I'm going to remove all this because we no longer need it, and we're going to switch back to Spring Cloud Stream. So Spring Cloud Stream, I'm going to go back to my pump file. I'm going to remove Spring Cloud Function from it, and all I'm going to do is just add Spring Cloud Stream binder rabbit, because now transitively it will pull Spring Cloud Stream core, and it will pull obviously Spring Cloud function. So now, again, I only have one single function. I'm going to show you that my configuration file is completely empty. Well, not, but everything is commented out, right? So my code only has one bean of type uppercase, and there's nothing hidden behind the scenes. So, and my POM file only has one dependency called Spring Cloud Stream binder rabbit. So let's end my rabbit is running. I'm going to clean it up just to make sure that we have a clean slate. All right, refresh. Okay, so we're clean. There's nothing there. So I'm going to start the application. Okay, and the application started. So now we can see this extra like within the exchanges. We see like we have uppercase in 0, uppercase out 0. So these are the destinations that were created automatically for you by simply starting the application. If those destinations existed, then we would use them. If not, we'll create them. So auto provisioning, you just saw how auto provisioning works right out of the box. So obviously I didn't have to worry about creating connection factory, session factory, none of that stuff. So Spring Cloud Stream provides all that for you through default configuration. So again, convention over configuration, sensible defaults. That's pretty much how Spring Boot looks at it and how we look at it when we're creating frameworks that sit on top of Spring Boot. So we'll give you the default. If you want to override this, then of course, like for example, if you're running it on different host port number and other configurations. So that's why I said we have many configuration properties where you can start adding to. But by default, I have it running locally, known port, known host. So a lot of things happen, right? So again, because I only had a single functional bean, it created automatically. Let's say if I add another one, none of this would happen. Why? Because we would have to say, okay, well, which one of those beans do you want to actually create a binding on? Because one of the things that we provide within Spring Cloud Function is a function composition. Just because I may have a couple of beans doesn't necessarily of type function doesn't necessarily mean that I need two bindings, right? I may just want to be able to, because each time you create a binding, that creates an input and output endpoint. So you're always leaving your code into the messaging system and then coming back, and leaving and coming back, and leaving and coming back. If you want to basically break down your functionality, hi Jonathan, if you want to break down your functionality in simple pieces and then compose it using function composition, that's a very good approach. So at this point of time, you're going to use function composition. So how would you do that? So let's look at it really quick. So I have a little cheat sheet with my, the demos that I wanted to show you, and I forgot to take it out. So anyway, let's look at it real quick. So I have another function here that's called concat, which basically concatenates two strings together, right? So, and what I'm going to do now, so if I try to start, application right now, as I showed you before, well, those exchanges were created from before, but we have no queues, right? Because it doesn't really know what, like I said, I have two functions right now. So what I'm going to do, I'm going to go back in my configuration and start saying adding things. So one of the first thing, or one of the main thing that, one of the main properties that you have to know, which is Spring Cloud function definition. So in this case, I'm going to do uppercase pipe concat. So what it's going to do, it's going to create a single binding for the composed function. So now let's look at this. So now we have uppercase concat in 0, right? Which is bound to the queue. Everything is fine. Everything is good. And I can send a message. And the message went through. You can see I didn't spell it right, but the message was uppercasing, concatenating, and everything else, right? So we can see that the data went through. All right, back to the presentation before we get back to the demos. Any questions so far? All right. So the key features within Spring Cloud Stream of today. So first of all, we're important to understand because we do have a lot of Stack Overflow questions and the GitHub issues where people, say I'm using this and it doesn't no longer work. We're at the version 4.1 right now. Anything below that is already EOL. So it's an end of life. Unless you're a commercial customer, we no longer support it. So 4.1.x, any kind of 4.1 version right now is the latest supported version, right? So what has happened in the past sort of 3-4 years that we've been working on a framework? Well, this list represents just a small subset, but let's just talk a little bit about this really quick, because some of these things I'm just going to discuss, some of these things I'm going to actually do the demo for. So ability to propagate custom beans across child application context via shared beans. So for those of you who are new to Spring Cloud Stream, obviously it's maybe it will be a little difficult to understand, but for those of you who are sort of seasoned users, you remember that sometimes there are certain edge cases where you need to configure additional beans or override existing beans, like for example, retry template or various different customizers and everything else. The problem starts when we create, the problem begins actually when we let me rephrase it. When you, the architecture currently within Spring Cloud Stream is that when you create a binder, when you define a binder, the binder is actually running in a separate application context. And in 70% of cases, we can define parent-child relationship. So in other words, if you define the bean, which obviously going to be running within your application, within your main application context, and the binder is a child application context, that bean is still visible to the child application context because of the parent-child relationship. However, there are certain cases, and I'll discuss them a bit later today, that where traditional parent-child relationship could not be set up between the parent-child, which is your application, and a child context as a binder. And therefore, in those type of cases, when you define some type of customization bean that's supposed to be applied on a binder, it's actually not visible to that binder because it's sitting in an application context that has no, to which there is no visibility from the binder application context. So we had a few hacks throughout the years, and eventually decided to formalize this approach by creating a concept of a shared beans, where just to simplify it for the users, because a lot of times you can create your own type of beans that are not known to the framework, but you still want to be able to access them within the binder context. So you simply define the type of classes that are needed to be propagated, and what we do during initialization, we scan through that list, and if we find a bean of that type in the parent application context, we simply create a copy or reference, declare the reference to that bean within the child application context, so now it becomes visible that way, right? So it's still a bit of a hack, but as you want to get to the end of it, we have right now even rethinking that, because we're trying to eliminate completely the concept of a parent-child relationship between a binder and an application, but we'll get to it. So ability to pre-configure dynamic destinations and bindings. So what you saw earlier is that everything happens pretty much automatically if you have a single function. However, if you have multiple, we also have this concept of a stream bridge, which is the ability to send anywhere, and it will, again, the same way it will create the binding for you and so on and so forth. But sometimes when you, basically concept of the dynamic destinations, where you have to, where you don't know ahead of time where the output should go, right? That is great, but sometimes those dynamic destinations still need to be configured, still need to carry certain configurations. So what we were able to do is to say, listen, it may be the dynamic destination, but there still need to be configured with consumer group partitions and a variety of different things. So what we're able to do, instead of defining a function that will automatically facilitate the creation of a binding, we can create a binding without even a function, and then configure it properly, and then you can obviously use it for sending and receiving messages from that binding. however those messages arrive there. So again, we're going to see that fully migrated to Spring Cloud Function. So interesting thing that I wanted to show you, again, for those of you who have used Spring Cloud Stream before, this is how it was before. Oh. This is how it was before. So you can see we had like a Spring Boot application, then we had enable binding, whether it's a source processor or a sink. Then we had a stream method annotated as a stream listener and everything. So the problem with this approach was when I took over the framework is that I'm not a big fan of annotations to begin with. But to me, the problem was not even annotations. The problem was mixed configuration, because you carry some configuration within annotations, some configuration was an external properties file. So now you're like chasing, like, where is the problem? Where could be the problem? So I'm like, pick a side, keep it there, and every time you try to create a new configuration property, think what the sensible default would be. Is it really necessary? Is there any other approaches, and so on? So we were able to keep it pretty tight, pretty clean right now. Of course, there's few issues, but we're trying. But again, this is how it was before Spring Cloud Function. And right now, as I said, we fully migrated to Spring Cloud Function. So you simply create, as you saw, a bean of type function, supplier or consumer, and that's all you need to do as a programmer. Okay, so GraalVM native support, pretty much everybody right now into ensuring that their frameworks, that their code is a GraalVM native compatible. And even though, you know, it's a GraalVM, it's a Java, it's supposed to be write once, write anywhere. Well, it's not always that simple. So we needed to pretty much within the entire Spring stack, not just Spring Cloud, not just Spring Cloud Stream or Function, we needed to make our code, let's just say, GraalVM friendly. Let's just leave it at that. So some refactoring was necessary. Observability, that's another big thing right now, and Jonathan here is the guy. Post-processing function, that was a very interesting request from the community, because as you already sort of getting familiar with function composition and already saw how it works, you can say, okay, well, if I want to post-process, do something after my main pipeline executed, just compose the post-processing function. Well, not exactly, because within the concept of Spring Cloud Stream, the cycle doesn't end when you finish your code. The cycle ends when the message went out, right? And that's when you want to post-process. So we added that functionality. Event routing, which is another interesting thing. And again, I'm going to be showing you all these things shortly, which is ability to, instead of creating multiple bindings and say, I'm going to send it here, send it there, send it there, send it there, you can say, okay, well, I'm going to expose only single function, single binding, much easier to maintain, send everything to it, and internally, based on the spell expression or based on a message header or a variety of different things, it's going to route to the actual function that needs to be invoked and process the input, right? Support for bifunction. Again, we try within Spring, historically, we try to keep things POJA, right? So a lot of times you only care about the payload, which is fine, but sometimes you need to receive message headers. So two ways of doing it. You could, and again, I'll be showing it to you. You could declare your function that receives a message, but now message becomes a Spring abstraction. So now your code contains import org.springframework.whatever, right? Or you can say you use bifunction and say like uppercase string, comma, map, comma, whatever. And we know that within a bifunction, if your second argument is a map, we're going to inject message headers, and now you have access to the message headers in a very simple POJA type way. So, like I said, with configurations, I mean, again, there's a lot of configuration. There is a whole sections within the documentation about various different configurations, but just a few to mention with regards to what happened in the last couple of years. So first of all, we're trying to stick as much as possible to conventional configuration. So, so as you saw, the Spring Cloud function definition is the only thing you need to identify function, and you can use that to compose functions. You can use another delimiter to say, listen, I want to do the multiple functions and so on. We're going to see it all in a second. So binding mappings. One thing you probably saw or noticed when I when it created exchange, you can see it's uppercase concat in 0. I'll explain the in 0 in a second too. But look at this name. Now imagine you compose 10 functions. How cool the name would be. And now what's interesting is like when we start seeing it, I'm going to show you some of the configuration properties, you will quickly see that that name is used within the configuration property, within configuration properties. So now typing that name and you know, it's not a real word, so it becomes very cumbersome. So what we provide is ability to say, listen, you have that, you can map it to a more, like map it to a thing called input or output or whatever it is you want to map it to, and then you refer to that name. So you basically remap this composed name into something much simpler, and then from that point on, you can just rely on that name. Okay? All right. So actuator endpoints allows you access to your bindings, also not just to read access, but also, you know, start, stop, and so on and so forth. Routing, again, I'll be showing it to you. I already sort of explained it. Ability to receive the events by a function called routing function, and then a routing function based on message headers or spell expressions will route to a specific function within your application context. Content type negotiation. As I said, you rarely have to. We provide transparent type conversion. So, in fact, within Spring Cloud Stream, everything travels on the edges as a byte array, and then if you have a POJO, we'll convert to it. Generally, the most sort of popular input type is JSON. So obviously, we have a converter for that. We have about a stack of 5 converters. And the way the type conversion works, we're going to look at some of the information like the content type and other information you provide, and basically ping this converter, that converter, and kind of go through the stack until we either convert or can convert. At that point of time, you will receive, we'll try to invoke your function with a byte array, and you'll probably get a class cast exception, and that means that you don't have a proper converter. You either have to fix the bug, something happened, or you have to define a custom converter, which we provide, we allow for that. So now, if time allows, I'll demonstrate that as well. So the bottom line is that we have converters that historically proven to work for 90% of the cases, but it's always that 10% where you can configure your own message converter, and it will be added to the stack and used. So StreamBridge, that's a very interesting story, a component that came out of Marcin's request to do something with it. Marcin is one of our one of my colleagues who works on the Spring Cloud, also with the Spring Cloud team on a variety of different projects, and he asked me to do something for him to facilitate the testing. We created this component, and right now it's like one of the most popular components within Spring Cloud Stream, and I'll definitely going to show you what it is used for and how it is used. But basically, its ability to connect non-stream application with its ability to connect stream applications with the outside world. But like I said, the funny story is that while it was created to facilitate the testing for, I believe, Spring Cloud Contract framework, once it became public, just people started using it. But here's the important part. How many are using, use JMS, JDBC within Spring context? You're familiar with the concept of a template, like JDBC template, Rabbit template, Kafka template, the asterisk template. So StreamBridge, on the surface, you will say, oh, it's just like a template. Just like, but not template, right? So it's not designed to be a template. It's not designed to be a replacement for the template. It's only designed to work to carry some of the features of the messaging template only within the context of a Spring Cloud Stream. And that's important because a lot of times people on the GitHub will either ask the question or ask for the feature within Spring Cloud, within StreamBridge. And I'm like, well, no, this goes outside of scope, outside of initial design scope. Like, we don't want to, first of all, compete with our own framework. Second of all, I don't want to introduce more features into the StreamBridge that will go outside of the architectural scope of the actual framework it supports. So it's important to understand not to mistake StreamBridge with, let's say, Rabbit template or Kafka template, even if you're working with Kafka or Rabbit. Okay. So at this point of time, we're probably going to do the demo for the rest of it. So and this is where that cheat sheet is going to be helpful. So we just saw a very basic Spring Cloud Stream app, right? So let's, first of all, let's add, like I just talked to you about Stream Bridge. So I'm like looking at the time. I just want to make sure I have enough. So let's say I'm going to comment all this out, right? I'm going to have a consumer. So we're going to show the Stream Bridge, right? So I'm going to have a consumer called consumer. I'm going to clean everything, right? So now what I wanted to do is I want to be able to begin my stream, right? But I want to receive requests from HTTP. How would I do that, right? So first of all, I'm going to go back to here, and I'm going to add. Again, this goes back to Spring Cloud function. We just add auto configuration. We just add a dependency, and all of a sudden provides us with additional capability, additional functionality. So by simply adding Spring Cloud function web, what it will do, it will expose my function as a REST endpoint, right? So so now if I try to start it, stop. Oh, a second. I need to do both of those, right? So if I try to start it, and you can see it says consuming Oleg. So I didn't do anything within the code. It was just a consumer, but it became a REST endpoint. Now, look what I'm going to do. I'm going to say and I'm going to say so basically, full bar in this case means any kind of name. So remember, I said this is specifically Stream Bridge was designed to send to do two things: ability to connect outside world with a messaging system, also to be able to handle dynamic bindings. So you don't know where you want to send it to. All of a sudden, some message header comes in and says you have to send it to full bar. Send it to full bar. So it doesn't really know whether it exists or not. It assumes that, but because it's sending it to a binding, the Spring Cloud Stream will automatically either create a binding or will use the existing one. So I'm going to start it again. I'm going to execute the same curl command. Now, besides the log, we're going to go back here. And we see full bar, and we see that it received a message that it was active, right? So all of a sudden, we just connected, like within seconds, we just connected the non-stream world with the stream world. And this is what became sort of one of the more popular sort of use cases for using Stream Bridge to accomplish that goal. So function routing. So I'm trying to pick which ones I'll have time to demo. Okay, function routing. So let's go back to and remove the consumer for now. So I'll do the cleaning here. So I'm going to re-expose. I'm going to re-expose the uppercase, and I'm going to re-expose the concat function, right? So all is good. Okay, so now I'm going to go to configuration. You see Spring Cloud function definition, and I use uppercase pipe concat. But if I put uppercase semicolon concat, what's going to happen is now it's going to create two bindings. We're going to see within RabbitMQ, we have uppercase and concat, right? So now imagine you have, and again, you can obviously do uppercase, pipe something else, and then column, concat, and so you can define as much as you want, right? Part of the problem is that when you have multiple bindings, you always have to think about maintenance and management of it, right? So how much are you willing to maintain? Because now you, within your code, somewhere that routing decision has to be made. Should I send it to uppercase or should I send it to concat, right? So you can delegate, the routing decision will still have to be made, right? Or communicated, right? So we can make routing decision for you as long as you communicate it to us properly, okay? So how would you do that? So in other words, right now you can send it to either concat or to uppercase, or we can shut this down and we can simply say, we can even comment this out. We can simply say sprinkler function, stream function, routing enabled equals true, right? And at this point of time, if I try to start the application, we have function router, which is provided by the framework. You don't have to do anything other than say enable routing equals true. It becomes available to you. So now, if I try to send message to it, I need to, there's a spell way of doing it, like spell expression, or just simply provide a message header called Spring Cloud function definition. So in other words, the same property that I use here, Spring Cloud function definition, to statically define which functions that I want to bind, I'm simply saying here that headers, Spring Cloud function definition, uppercase, hello, right? And now I'm going to send message to the routing function. And what the routing function did is actually, come on, what's going on? It sent it to uppercase. If I, within the same function, if I say, now it's concatenating hello, right? So again, a benefit of this is that you have a single function to maintain, or actually not to maintain, you're not even defining it. So it's just a functionality provided by the framework, and you can, but you don't need to multiple bindings to maintain, and you can do the internal routing. And again, it's a question of security and other things as well, right? So everything's sitting behind, nothing's exposed, other than within the application context, and you can, yeah. And again, when you provide this header, it's the same property. So the same rule for composition apply here. So I can say uppercase pipe concat, and now uppercasing, concatenating, right? We already have 3 minutes, Jesus Christ. I showed you StreamBridge, I showed you this. Post-processing also became a very important, I talked to you about it a little earlier, but post-processing became a very important, and all of a sudden it's like we lived for 5 years without anybody ever asking for it, then all of a sudden somebody asked for it, and now it's becoming also a rather popular feature. So post-processing, what's interesting about this is, like I said, you already know about composition. You can say, okay, well, I include the post-processing function, just compose it at the end, and that's going to be my post-processing. The problem is understanding the life cycle of streaming applications. So your code execution is just the middle life cycle. So there's a cycle, the full life cycle means arrival of the message, type conversion, all that other stuff, and then message being sent out. And then at this point of time, you know, a message went out, everything went successfully, and you can say, okay, the cycle has completed. So somebody was asking, like, how can we do some type of post-processing after the full cycle complete? So we implemented a post-processing function. So the quick way of looking at it is to say, okay, well, I'm going to, you saw the uppercase, so I'm going to do a slight modification and simply do this. And I have this class called post-processing function. The difference is very minimal, except that it is a sort of a semi-marker function because we look at post-processing function, we know what to do with it, right? And it has one additional method called post-process. So you can implement it, and this is going to be invoked by the framework after the message has been sent and everything's done, right? So if you're implementing the new function and you need a post-processing like that, you can do it. Now the question is, what if I already have a stack of functions? What if everything is working, but now I want to add post-processing and I don't want to touch my functions? I don't want to change some of my functions to post-processing functions. What can you do? You can simply implement a new post-processing function and compose it at the end. What's going to happen is that you're not implementing the apply method, so it's going to be a simple pass-through, but now the framework sees a post-processing function and it's still going to invoke that post-process method at the end. So quickly, starting up. Oh, come on. Oh. Did it send a message? That's interesting. Uppercase. Anyway, okay. Let me just do it differently. It didn't work with the. You just saw a bug being discovered live, so to speak. So it doesn't work with the routing function. So I need to look at it. But I can go back to the very basic things, and oh, I think I know what happened. But anyway, maybe it did work. But you can see the log message saying post-processed and everything else, right? So, guys, we're kind of out of time. So let me quickly rehash. You know, these demos, it's very hard to time when you have 45 minutes to do a lot of them. So let me quickly rehash what we. So we've seen post-processing function. We've seen event routing. I mean, I wish I could show you more. Obviously, catch me here if you have any questions. Support for bifunction, I explained it to you, but basically what it would entail is for you to simply change this function, let's say, to bifunction, and instead of receiving just a payload, you would include map, and now that map will contain the actual message headers. You could also say function message, comma string, but then you would be forced into Spring sort of a messaging abstraction. But this is how you can keep it POJA way. Oh, I didn't. Sorry. This is what I meant, right? So just bifunction string map, and that's what it would be like. So observability, haven't had a chance to show you, but I'm sure there's plenty of material out there. It's just, again, a matter of adding two auto configurations like the micrometer and, for example, if you just want it for logging, Brave thing, and it's just you'll see tracing information within your application. Sanitizing, like actuator data, like actuator, again, a very simple way, just add actuator, and there's a small section, add actuator dependency, and add one single property, and now all of a sudden your binding information is going to be available on via HTTP, not just for reading, but also for writing. So that's, and we have it right now, because it now can display sort of a sensitive data, we provided the sanitization function, which is, again, comes from Spring Boot, allows you to sort of mask the data. So I'm going to skip the binders. Oh, one last thing that I want to talk to you about before I really have to get off the stage. Yeah, reactive functions we support, just like imperative. But be very careful. Imperative function is a message handler. That's the one we wrap That's the one we invoke. That's the one we control. Reactive function, imperative function is invoked each time the message arrives. Reactive function is invoked only once during initialization. The job of the reactive function is to connect the stream that you define within your code with the input and output. Once it's connected, it's almost as if you shut down Spring Cloud Stream. We don't have any control or visibility of what's going on. So when you're talking about features like error handling, retries, and as well as the observability, there is sections that explain that. So read on that and make sure you understand there's a fundamental difference between the two functions. So don't expect reactive functions work the same way as imperative functions. Guys, I need to get off the stage. I'm so sorry. Like we ran out. I'll be right here if you have any questions. I still have tons of them. I can maybe hack something up for you. So thank you so much.